Hello dear students, thanks to all for watching my lecture. Today we will learn moment of inertia. Already we learned moment of inertia and we applied two special theorems. One is parallel axis theorem and another is perpendicular axis theorem. Okay, already we learned moment of inertia for different shape of the object. Which type of the shape already we have completed. Now we discuss. Okay, my dear student, already we discuss uniform rod. In case of the uniform rod, the moment of inertia, suppose this is a uniform rod. If the length of this rod is L is length and M is mass. Okay, this is the uniform rod. Okay, if the rotational axis passing through the side of the object, suppose AB is the uniform rod, and if this is the rotational axis x prime, and if this rotational axis passing through the side of the object or uniform rod and perpendicular with the length, then the moment of inertia in this case is ml squared divided 3. M is a mass of the uniform rod or L is a length of the uniform rod. My dear student, if the rotational axis passing through the mid side of the uniform rod, suppose this is AB uniform rod, and if x prime is a rotational axis, and if this axis passing through the mid side of the uniform rod, in these cases the moment of inertia will be ml squared divided 12. In our previous lecture already we have learned. Okay, my dear student, if you do not see this lecture, then please at first see this lecture, then come here. Okay, now today I try to find out moment of inertia another type of the disc. First I describe in case of the circular disc, then cylinder. Okay. Let we discuss at first of circular discs. Okay. Suppose this is the circular disc. This is the circular disc. Okay. The radius of this circular disc is R. R is the radius. Okay. Radius. Suppose this is the circular disc. Okay, this is the circular disc. This is the center of the circle, and this is the radius of the circular disc. In case of the circular disc, in case of circular disc. Okay. The mass of this circular disc is m. M is a mass. Okay. R is a radius. R is a radius. My dear students, if the rotational axis passing through the center of the circular disc, suppose this is the rotational axis, and this name of this rotational axis is x prime. Suppose this is the direction of the rotation. If this rotational axis passing through the center, suppose O is a center of the circular disc, and if this rotational axis passing through the center of the circle and perpendicular with the circular disc, that means the name of the rotational axis is normal. Okay, this is normal. According to this axis, we try to find out the moment of inertia of the circular disc. Okay. At first, our concept is to find out the moment of inertia very small part. Suppose our equation is mr squared. This is the equation to find out the moment of inertia of a point mass. Suppose if this is the rotational axis x prime, and if this is a point mass, and if this is a perpendicular distance, then this is the rotational path, and the moment of inertia of this particular point of the mass is m, and perpendicular distance between rotational axis and mass is r. So m r square. Okay, my dear student, I think all of you clearly understand. Okay, now our concept is, at first we take very small section or very small part of this circular disc. How we find this? Suppose the area of this circular disc is A. A is the total area of the circular disc, and for the A area, the total mass of the circular disc is capital M. In case of the per unit area, the total mass will be M divided A. Already we can write the equation of the area pi r square. Pi r square is the area of the circular disc. So we can put here M divided pi r square. Now we take a very small section. Suppose this is a very small section. This is very small section. Okay. At first we have to find out the mass of this very small section. Suppose the width of this small section is dx, very small amount of the width, and radius of this is the total radius, this is the total radius of the circular disc, and this is the x is the radius of the smallest section. The length of the smallest section or width of the smallest section is very small, dx, and this is the radius. So we can write this is twice pi x is the circumference. Okay. So at first we have to find out the area of this cross sectional area. Okay. How we can find out this? We can find out this by applying the law of area, pi r square. So here we can see the area is twice pi r is the circumference, and if we multiply very small with dx, then we get the area of the smallest, very smallest part. Okay, this is the very smallest part, and because of this smallest part, the mass will be very small dm, and area will be, this smallest section area will be dA. How we can find out this area? Suppose this is the circumference of the smallest region. At first we put here circumference and we multiply with width. Why we use this equation to find out the area? Because if we straight this path, then this path look like as this. Okay, this is the circumference 2 pi x, and this is the width. So according to the find out the area, we multiply length and width. Okay, this is the equation of the area. So the length will be exactly equal to the circumference of the circle. That's why we write twice pi r, so twice pi x and multiply dx. Okay, so we can write this is the very smallest area of the cross sectional part. Okay, so the area for 1 unit mass, already we for 1 unit area, the mass of the circular disc will be m divided pi r square. So in case of the dA area, so we can write m divided pi r square dA. So this mass will be very small, and this small mass will be m divided pi r square. The value of dx will be twice pi r into dx. So we can cancel out, pi cancel out, 2m divided 2m divided r square x into dx. This is the very small mass for the cross sectional area. I think all of you clearly understand. Now we write the equation of the moment of inertia. Let the moment of inertia very smallest will be the smallest section, di is equal to dm into x square. This is the equation. Where we get this equation? We know the equation of moment of inertia, I is equal to mr square. This is the equation. As we get the moment of inertia, this very smallest section dm, we already find out the mass of dm, and we multiply perpendicular distance x, perpendicular distance square distance x square. If we put the value of very smallest mass dm, the value dm is 2m divided r square x into dx. Now we rearrange this equation, 2m divided r square x cube into dx. This is the equation. Here this equation represents the moment of inertia of this very smallest cross sectional part. Okay. Now our duty is to measure the moment of inertia for whole circular disc. Already this equation represent the moment of inertia, this shadow region. Okay. Because of the shadow region, the moment of is very small. As the shadow region is very small, so moment of inertia also very small. If we integrate this equation, then we get the total moment of inertia for the total whole circle. Okay. Now we write here I means total moment of inertia for the full circular disc. Now we integrate this part, 2m divided r square x cube dx. Now our value of this x will be lower limit here. Lower limit of x is 0 and upper limit of x is exactly equal to the r. So lower limit we put here 0 and upper limit r. In this region, if we integrate within x value 0 and x to r, then we get the total circular disc, moment of inertia for total circular disc. Now we complete this equation. We know here integrate with respect to x axis. So 2m divided r square come out from the integration part. This is the constant, 2m divided r square. So we know the value of a power of x is 3. So we add here 1, that means 4 divided 4. Okay, we know these basic rules. 0 into r. 2m divided r square, we come out 4 as a constant part. Now we put the limit here. So our upper limit is r. So at first we put the upper limit, replace x by r, power is 4. Now we write minus and put 0, replace by r, replace by x, sorry, 0 replaced by x. After solving this part, then we get 2m divided, suppose we write here m r power 4 and 2 r square. So finally we get m r square divided 2. So our moment of inertia of this circular disc, in case of the normal, the moment of inertia will be m r square divided 2. My dear student, I think that all of you clearly understand. Now we find out the moment of inertia in case of the cylinder. Okay, in case of the cylinder, we also find moment of inertia by integrating method. How can we do this? Okay, suppose if this is not a circular disc, always remember that in case of the circular disc, moment of inertia will be m r square divided 2 if the rotational axis is the normal and passing through the center. But in case of the cylinder, how can we find this? Just I try to discuss you. Suppose this is a cylinder, uniform nearest cylinder or the solid cylinder. This is the solid cylinder, this is cylinder, and this is the rotational axis. X prime is the rotational axis. This is the direction of the rotation, and the length of the cylinder is L, and cross sectional radius of the cylinder is R. In case of cylinder, my dear student, in case of the cylinder, we try to find out the moment of inertia. At first, our duty is to find out the area of the cylinder, total area. Total area of the cylinder will be twice pi r square L. This is the area of the cylinder. Suppose the mass of the cylinder is m. M is a mass. Okay, m is a mass of the cylinder. In case of pi r square, the whole area, the mass will be m. In case of 1 unit area, the mass will be m divided pi r square L. Okay. Now our duty is to find out the very smallest cross section mass of the smallest cross section area. After finding the mass of the smallest cross section area, then we apply the law of moment of inertia. Okay, suppose this is the very smallest section, and this cross section area width is very small dx. Okay, this is the cross section area, very small cross section area. This is very smallest cross section area. Our duty is to find out the area of this cross sectional part. Okay, we learn in our previous lecture circumference will be twice by x. Okay, circumference will be twice by x because this distance is x. The radius of this cross sectional area, if the radius of this cross sectional area is x, then the circumference will be twice by x. And if we find out the area of this cross sectional part, then our duty is to find at first area of this cross sectional part. Area, suppose the area will be very small, dA. I think that all of you clearly understand dA. The value of dA will be twice pi x and dx. Okay, so we try to find out the volume of this part. So sorry, this is the volume, this is the total volume V. The pi r square L is the volume of the cylinder. Okay, not area. Okay, this is the volume of the cylinder. My dear student, you just try to understand. This is the volume, this is volume, not area. Okay, now our duty is to find out the volume of this very smallest cross sectional area. We know the volume. Here we can see the formula of volume. Formula of volume will be pi r square L. Pi r square means area, and L means length. This is the equation to find out the volume of a cylinder. If the cross sectional area is shadow region is very small, twice pi x into dx. If we multiply with the length, then we get the total area of this shadow region. So total area, not area, volume. Total volume will be very small dV. Okay. Now our duty is to find out the mass of this volume. Already we write for pi r square L volume, the total mass will be m. For 1 unit volume, the total mass will be m divided pi r square L. In case of dv volume, the mass will be m divided by r square L into dv. This can be noted by dm. Okay, m divided by r square L, the value of dv will be twice pi x into dx into L. M is the total mass. Okay, here we get the total mass of the cross sectional area. That will be very small because the section will be very small. M divided pi cancel out, so we can write 2m. R square L will be cancel out. Here x are present here, x dx. This is the very smallest mass of this region. Now we find out the moment of inertia will be very small, di. We write mass, and mass of this very small section will be dm, and distance is x. So we multiply x square. Di, the value of dm will be 2m divided r square, x dx and x square. If we multiply 2m divided r square, x cube dx, this is the equation. This equation represents the moment of inertia, very small spot. Okay. Now our duty is to find out the moment of inertia for whole solid cylinder. Now we just find very smallest cross sectional area, moment of inertia for very small spot. Okay. Now our duty is to find out the moment of inertia for whole cylinder. Then what rules we can apply here? Integrate. Now we integrate this equation. Suppose the total moment of inertia will be I, and if we integrate 2m divided r square x cube dx, the value of x, here we can see value of x is 0, and here if we increase the length, the value of x will be exactly the radius. Okay, so lower limit is 0, upper limit is r. Okay, 2m divided r square is a constant, so this cannot be integrated. Okay, only we integrate x cube dx, lower limit 0, upper limit r. Okay, 2m divided r square, we know the equation, we add 1 of power of x, 4 divided 4, 0 to r. 2m divided r square, 4 will be come out from the integration part. We put the upper limit and we put the lower limit. So after solving this equation, we get mr squared 2. So moment of inertia of the cylinder and moment of inertia of circular disc will be same. Now our question is, why moment of inertia of a circular disc and a cylinder will be same? Because for find out the moment of inertia, always we take the perpendicular distance from the rotational axis. Try to understand. This is the x prime is a rotational axis. Always for find out the moment of inertia, we take the perpendicular distance. So radius here will be count out, and length of the cylinder cannot be counted. Okay. Now we discuss this, as this is the circular disc. If this is the normal, then moment of inertia will be this rotational axis, I is equal to m r square divided 2. In case of the solid cylinder, this is solid, this is the own axis, this is own axis, x prime is the own axis, r is a radius, m is the mass, this radius also r, mass is m, the moment of inertia will be same, mr square divided 2. Why same? Because try to understand, for calculating moment of inertia, always perpendicular distance will be count, not parallel distance. So if we make a cylinder of circular disc, then this is the material. So this length cannot be counted. Because of that reason, the moment of inertia of cylinder and circle will be same. My dear student, I think that all of you clearly understand. Already we learned moment of inertia for cylinder and circular disc. Thank you.